sugarcane Brazil basis is, of course, it will never be grown in the United States, but it gives you a measure of what is the area required somewhere else to satisfy the U.S. demand. Corn can have a contribution, but is again limited. Rapeseed, likewise. Continue with the issues affecting liquid biofuels. There is, in certain situations, the issue of food versus fuels, which is not the case of sugarcane, and even the case of corn. Because if you look at the supply of corn historically, it has satisfied both the food and the fuel markets. But there are situations in which this may be an issue. Access to raw materials, I already mentioned. There is an evolution in technology. There is the issue of sustainability. The demand side is pressing for more and more sustainability, especially in the international market. And the issue of certification, especially from Europe, in which the importers would want to confirm that the ethanol that was made in Brazil has met certain sustainability standard. And then comes the issue of international trade. As you all know, there's an international trade negotiations going on, more or less at the end, but it never reaches the end. Only end inside is mine, because I can see a placard in the back of the room. But international trade, we are at a Doha impasse in which biofuels are in the wrong column. Biodiesel is in the industrial products, and ethanol is in the agricultural product, and that brings problems. In spite of all of these difficulties, major companies are interested. Now, regarding the world fuel ethanol, again, the markets were created by mandates and subsidies, and in most cases, they still remain supported by that. In the case of Brazil, it's the dominant exporter. It has a large domestic demand, but it has to arbitrage with sugar. The trade barriers everywhere, and the U.S. corn-based ethanol has to face these difficulties that I mentioned, sustainability concerns and food versus fuel. And it's important, and we haven't gotten there yet, but it's important to have a well-established futures and option markets for price discovery of fuel ethanol, because that would characterize ethanol as a fuel commodity. And this idea of certification is a two-edged sword, because it can be used as a trade limiting issue or barrier. In the world, there are many countries that are producing, but some should need imports. China is an example. It's a large producer, but also has a large market, and it will need to import. The truly liberalized global market in fuel ethanol is a vision in the distant future, but it is a necessity, and public policies towards that end, especially in the international arena, are required. Africa is definitely the new frontier in terms of availability of areas, and there are competition in this environment. And then to close, as you can see, my argument about sustainability of biofuels needing freer international trade, basic message here is that the countries in the South are much better equipped to produce with high yields and low cost the biofuels that are needed for the world. And the countries in the North, although they can produce some of that, they would need to import. And what we really need in this arena is what I call a biopact that recognizes that, harmonizes that, negotiates that, and implements it. Thank you.
Thank you very much, Sergio. We will now go to our second panelist, Mr. Professor Lee. Thank you. Who will talk about the potential of sweet sorghum as a renewable source of energy.
Thank you, Nayana. Good afternoon, ladies and gentlemen. It's my pleasure to give a talk about the challenges and the opportunities for the global development of biofuels. During these 2 days conference, many speakers talk about biofuels. I won't say any more about biofuels. We all know we need more biofuels. So last year, the total biofuel production was about 83 billion liters. and most biofuels are ethanol. So the challenges, so we need more. As we need more biofuels to meet the demand to replace oil and realize oil dependence. But the challenge is we haven't enough biofuels to meet the demand. For example, the biofuel trade barriers. And so many countries, if you import ethanol, will be tariff. So, and another challenge is for food security and sustainable production of biofuel and the cost competitive with oils. These challenges. So, we hope free biofuel trade. So in Chinese government already lowered the ethanol import tariff from 30% to 5% on 1st January 2010. And so now China is considering to import ethanol from abroad, especially from Brazil. And so. And the challenges so give the opportunities for the development of biofuels, especially for developing new feedstocks and also new technologies. New feedstocks may be some not only like the Kostler yesterday said, biomass is not only sugarcane. Maybe we can some other new feedstocks I will talk about later. And the new technologies, not only first generation biofuels, we can 1.5 generation technologies, second generation biotechnologies, or cellulosic fuels, and the third generation biofuel, algae fuels, and fourth generation biofuels, and photosynthesis fuels. So. First, I'll talk about 1.5 generation biofuels. This is sweet sorghum. We all know from the first generation corn and the sugarcane, and will threaten food security. And also for second generation cellulosic fuels will not be commercialized. So we shouldn't wait for emerging technologies, and we should use available technologies. So sweet sorghum, and Dr. Buchanan, the former Undersecretary of USDA, regarded sweet sorghum as the 1.5 generation biofuel because for sweet sorghum integrated the advantages of corn and the sugar cane, and the sorghum grain like a corn can supply food and feed, and the stalks is rich of sucrose like sugar cane. We can use the sucrose to produce ethanol, and the fermented bagasse can be cattle feed to feed cattle and the sheep, and also can be boiler fuel to generate steam and power. So, and that's why 1.5 generation biofuels. So, why sweet sorghum? And because sweet sorghum originated from in African countries, so it is high tolerance to drought, alkali and saline. It can grow on marginal lands, and it is suitable to more areas. For example, this is a report issued by FAO, United Nations. And this is the bioenergy and the food security analysis for Tanzania. For Tanzania, and for sugar cane, the suitable area for growing sugar cane only 1 million hectares. But for sweet sorghum, it's about 69.5 million hectares. It's about 70 times. That's why we prefer 1.5 generation sweet sorghum, because it can suitable to more areas. Currently, only United States use corn to produce ethanol and sugar, and in Brazil the sugar cane ethanol. But sugar cane only grow on tropical and semi-tropical area. But sweet sorghum and the sweet sorghum can grow all over the world. And another reason for sugar cane, the growing time normally 10 to 12 months. And for sweet sorghum, only 3 to 4 months. So that means one harvest of sugar cane and 3 harvests of sweet sorghum. we can increase the land efficiency. Use the same land, same amounts of land to produce more fuels and more greens and more power. So that's why I introduced a technology named Advanced Solid-State Fermentation Technology. We all know in Brazil, use juice fermentation technology to press the sugar cane, obtain the juice for fermentation is easy. But the problem is when you're pressing the cane, you consume lots of energy, electricity, and you can't extract sugar completely from the bagasse. Normally 5% remain in the bagasse. And the third is the waste treatment issues. So if we use solid-state fermentation technologies, you can just smash the cane and just put the cane into the solid-state ferment. It's a rotary drum ferment and a continuous solid-state ferment. After 24 hours fermentation, so you can continuous distillation. In gaseous state is ethanol, and in solid state is a fermented bagasse. Its nutrient is the same like corn salad. You can feed cattle in the feed. You can also use the bagasse to generate electricity and the steam to use using in ethanol production process. This is rotary drum ferment, continuous solid state ferment. Is 3.6 meters in diameter and 55 meters long. It's a huge solid state ferment. And so SSL plant is very simple. Only chopper machine to smash the cane, use fermenter to the ferment and the distillation and the dehydration. It's very simple. Low educated laborers can run this plant. And so, there is no software to drive it. And why as a solid state fermentation? So because after the fermentation of the bagasse, we test and the composition. We can use the fermented bagasse to produce cellulosic ethanol. We all know the lignocellulose contains the hemicellulose, cellulose, and lignin. Lignin includes lignin G, lignin S, and lignin H. Lignin S has a high resistance for enzymatic hydrolysis. So during my process after solid-state fermentation, 24 hours of fermentation, lignin S, the content decreased about 30%. It is easy for hydrolysis, enzymatic hydrolysis. That's why so we can use solid-state fermentation two models. And one model is the fuel and the feed models. We use the sorghum grain for food, and the sorghum stalks of solid-state fermentation. After fermentation, use the bagasse to feed cattle manure to produce biogas and organic fertilizer to grow sweet sorghum. And another model is the fuel and the power models. So after the fermentation, we use the fermented bagasse to generate the power. Normally, 10,000 metric ton ethanol plant will affiliate with 2.5 megawatt biopower plant. So if we currently use from the first generation to 1.5 generation biofuel, and then maybe in the post 2015, second generation cellulosic ethanol will be commercialized, and maybe in the post 2020 we can commercialize algae fuels. In the future, we can use photosynthesis. I think we can use carbon dioxide and water to synthesize the fuels we want, to ethanol, butanol, and other hydrocarbons as fuel. So, thank you.
Thank you, Professor. Our third panelist is former Governor Chet Culver.